Hello and happy Thursday. Today we're going to go ahead and talk about constant of proportionality. But before we do, I'm going to go over the warm-up. The warm-up today asks that given the area of the circles shown, order them from greatest to least. So in order to order them from greatest to least, we have to be able to rewrite them. So we have 9 pi, the square root of 3 divided by 2, and 27 and 5/10. Well, 9 pi means 9 times pi. Now, if you don't know what pi is off the top of your head, I do want you to go ahead and open up your notebook. And I do want to point out that pi is a value that is found on your reference chart, on your 7th grade reference chart, and the value of pi, or the approximate value of pi that we're going to use, is 3.14. So with that being said, we know that pi is 3.14, so 9 times pi would be 9 times 3.14. How do I know it's multiplication? Because there is no operation sign in between those two. So 9 times 3.14, and I'll let you go ahead and do the multiplication on this, should come out to be 28.26. And remember, we have 2 decimal places, so our answer has 2 decimal places. So that's 28.26 on 9 times pi. Then you have the square root of 3 over 2. The square root of 3 is a imperfect square, or a non-perfect square. But we can approximate the value of the square root of 3 given that we know our perfect squares. And in this case, we know that our perfect squares are going to be the square root of 1 for 1 and the square root of 4 for 2, which means that the square root of 3 would fall precisely in the middle between 1 and 2, so 1.5. So we have 1.5 over 2, and 1.5 divided by 2, top in, bottom out, should give us 75 hundredths. So that means that the square root of 3 divided by 2 is 75 hundredths. And the last number is 27 and 5/10, which we don't need to do anything with. So remember, we're going to order these numbers from greatest to least. The greatest number is going to be 28 and 26 hundredths, which is circle X, followed by 27 and 5/10, which is circle Z, and lastly, circle Y with 75 hundredths. So circle X, circle Z, and circle Y, and that should give us answer choice C. Now, let's go ahead and talk about constant of proportionality. So let's break down what a constant of proportionality is. We know that a constant is a fixed number that does not change, and we know proportionality refers to proportions, which is equivalent ratios. So I'm going to go ahead and play a short video to introduce us to constant of proportionality, and then we'll address how we work with constant of proportionality this year.
One Saturday morning, you find yourself at the local grocery store helping out with a little shopping for your family. You've been asked to go pick up a can of tomatoes. When you get to the aisle, you see the brand you want on sale, 2 for $3. In your head, you divide 3 by 2 and know the tomato can will cost $1.50. What you just did, without even knowing it, is find...
What you also just did is found the unit rate. Now, unit rate, we talked about finding the unit rate.
The constant of proportionality for the cost of a tomato can. The constant of proportionality is the ratio between 2 directly proportional quantities. In our tomato example, that ratio is $3 divided by 2, which equals $1.50. 2 quantities are directly proportional when they increase and decrease.
I want you to go ahead and define directly proportional in your notebook. Again, to directly proportional is when your quantities increase and decrease at the same rate. That means when X is increasing, Y is also increasing. When X is decreasing, Y is also decreasing.
At the same rate. When you buy more or less, the total price of the tomato cans in this example goes up or down correspondingly. Even though the amount of tomato cans bought at the total price can change, the price for a single tomato can, our constant of proportionality, remains the same. This is why we call the constant of proportionality a constant, a number with a fixed value. In this lesson, we're going to look at multiple ways to identify the constant of proportionality. We'll see how to identify it in equations, word problems, diagrams, tables, and graphs.
Okay, so I'm going to go ahead and talk about that. So again, the connections that we see here is that our constant of proportionality corresponds directly to what we talked about finding unit rates. Okay? And also goes back to what we did earlier in this unit when we were figuring out the unit rates and we were creating tables for the amount of soda versus ounces, the amount of coffee, and whatnot. But before we talk about constant of proportionality, it's very important that we know the difference between an independent and dependent variable. Now, an independent variable is a variable that does not depend on another variable. And in other words, it's going to be your input or your x value. Your dependent variable is the variable whose value depends on another variable, and it's going to be your output and your y value. Go ahead and pause this video and also identify independent and dependent in your journal. Now, let's go ahead and practice with identifying independent and dependent and calculating unit rates and constants of proportionality given this situation. In this situation, a radio station played 30 songs in 5 hours. So, we're going to go ahead and make our input. By the way, when you're dealing with input and output or dependent and independent, and time is a variable, well, time is always going to be independent because time does not depend on anything. So in this case, because we're dealing with time, then time is going to be our x, our independent, and songs will be y. So now, given that we know that in 5 hours, we're going to play 30 songs, let's figure out the unit rate. And in order to figure out the unit rate, in just a second, because here my y doesn't look very y-ish, so I'm going to need to fix that. Remember what I was saying was that this is your y variable. So now, we have to figure out the unit rate. So the unit rate is going to be the number of songs divided by the number of songs divided by the time we've been given. And remember, the number of songs is our y variable, and the time we've been given is our x variable. So essentially what we're doing is we're dividing y divided by x, and 30 divided by 5 should give us 6. So 6 is our unit rate. That means that if we had 1 hour, there would be 6 songs. 2 hours, 12 songs. 3 hours, 18 songs. 4 hours, 24 songs. And 5 hours, 30 songs. Now let's go ahead and stop to label what we just did. When we figured out the unit rate, when we divided y over x, what we did is we found the constant, because the constant and the unit rate are the same thing. So I want you to write this down. K is constant, and the constant is going to be the same thing as your unit rates. Okay? Now, this is also another equation that you are going to find on your reference chart. So in this case, our K, or our constant, is going to be 6. That means, now that we have a table, let's create an equation for it. So in our equation, y, the number of songs, is going to depend on 6 times x, the number of hours. Let's use substitution. That means that if I had x is 1 hour, that's 6 times 1, which is 6. If I had 2 hours, that's 6 times 2, which is 12. If I had 3 hours, that's 6 times 3, which is 18. If I had 4 hours, that's 6 times 4, which is 24. And if I had 5 hours, that's 6 times, if I had 5 hours, that's 6 times 5, which is 30. So right here, what we just did is we created an equation. We identified the constant by finding our unit rate, and we created a table, all given this one scenario, which is what you're being asked to do in today's lesson. So, earlier I mentioned that your constant equation is found on your reference chart. I'm going to go ahead and point that out to you. So on your reference chart, we see that K, and it may not actually be, there it is. We see the constant of proportionality, and we see that K is equal to y over x. All right? See, so constant is identified on your reference chart, and it's going to be the ratio of y divided by x. So, let's go ahead and put into words what we just did. And these words are also going to go into your notebook. So, the constant of proportionality is the ratio of y divided by x within a relationship. This is the same as unit rate. So y equals kx is the equation for constant of proportionality, and in that equation, k is the constant of proportionality. I would like to find this equation written in your notebook as well as labeled. K needs to be labeled as the constant of proportionality. Y over x is the ratio. Now, we're going to go ahead and go into our foldable. So you should have your foldable at this point, and please pause if you do not have your foldable. In this example, we are going to take a verbal description just like we did earlier with the songs and the hours, and we're going to create a table, a graph, and an equation because we are identifying these proportional relationships. So in this verbal description, the tax on soda is 3 cents per ounce. That means that if I had 1 ounce of soda, that's 3 cents. If I had 2 ounces of soda, that's 6 cents. If I had 3 ounces of soda, that's 9 cents. And if I had 4 ounces of soda, that's 12 cents. So right there. So, now in this case, what is our unit rate? Well, our unit rate is going to be how much soda we get for 1 ounce, right? And remember, by the way, this is X, this is our input, this is our output, correct? Why is X our input? Because the cost, Y, is going to depend on the number of ounces. So the cost is independent and the number of ounces, I'm sorry, other way around. The cost is dependent on the number of ounces, which is independent. And so this is why our independent variable is X, which is number of ounces, and our dependent variable is Y, which is cost. So in this case, our unit rate is going to be cost over ounces, or Y over X. And Y over X is, as you can see, 3 over 1, or if we look at the original situation, yeah, 3 over 1. So our unit rate is 3 over 1, which means that our constant K is 3 over 1. So now, let's look at what that means on our table. If we're going to go ahead and graph the ordered pairs we just created, that's 1, 3, 2, 6, 3, 9, 3, 9, and 4, 12. I'm not going to just graph 4, 12, but you see the point. Now I'm going to go ahead and draw, this is a linear equation, so I'm going to go ahead and draw a line through my graph. Now, not all of my points go exactly, but that's because of my drawing and not due to the points. Now, let's take a look at one more point that we don't directly have on our graph. But if I were to buy 0 ounces of soda, how much would that cost? It should cost $0. So 0 ounces of soda costs $0, which means that 0, 0 is another point on this graph, or this graph goes through the origin, because as we've identified earlier this week, the origin is 0, 0. Now, this is a very important point for you to understand, because in order to identify whether a graph is a constant of, has a constant of proportionality or not, you have to look to whether the graph runs through the origin or not. Graphs that go through the origin are a constant of proportionality. If your graph does not go through the origin, then it is not a constant of proportionality. So, constant of proportionality graphs go through the origin. Now let's take a look at the equation. On our reference chart, or the equation we identified earlier, is y equals kx for constants of proportionality. We already know that our k is 3, so y equals 3x is going to be our equation. I'm going to stop right here, and then you're going to do the rest of the examples on your own. I'm going to go ahead and do example 2 with an elbow partner, and then the rest of the examples after that need to be solved independently. So I'm not going to go through this example. Your practice for today is going to be Khan Academy, and your homework for today is going to be Get More Math. If you have any confusions on this topic, once you've rewatched this video, once you've talked with an elbow partner, and if you still have confusions on this, then please go ahead and submit an exit ticket to me, letting me know that you have confusions on this so that we can go over it. Have a wonderful day.